Good day. Welcome to the second part of our discussion video on power series and their convergence. Before watching this video, make sure na napanood niyo na yung first part. Katulad ng sinabi ko sa first part, our goal is to find the radius and interval of convergence of the given power series. We have here 10 items to answer, 6 of which are exercises given in page 62 of Math 22 module. So far, we are able to answer items 1 to 2, and for number 3, we are able to answer the first half of the solution. I left the second half of the solution as an exercise or as an activity before proceeding to this second video. So I hope na ginawa niyo yung activity before watching this video. Alamin natin kung parehas ba tayo ng naging conclusion. For number 3, this is what we know so far. So ang alam lang natin, the radius of convergence is 1/2, and our possible interval of convergence is this one, or this one. So, in order for us to determine kung alin ba dito yung interval of convergence na hinahanap natin, let us check for the convergence of this infinite series when x is equal to 0 or when x is equal to 1. If x is equal to 0, this infinite series is just equal to this infinite series. As you can see, this is algebraic over algebraic. And sabi natin, if yung infinite series natin ay ganun yung form, isa sa recommended test na pwede natin gamitin ay yung LCP. But before you can apply LCP, you have to verify whether each term of the infinite series is positive. No? As you can see, our n here ranges from 4 to positive infinity. So if that is the case, square root of n squared minus 9 is always positive. Thus, this whole thing is always positive for all n. Thus, we can apply the limit comparison test. Let's call each term in this series to be b sub n. If that is the case, we have to look for another infinite series, say the infinite series of c sub n from 4 to positive infinity, where c sub n is positive for all n. Again, for us to apply the limit comparison test, we have to look for another infinite series, say this infinite series where c sub n is positive for all n. You go back to your infinite series. This is your infinite series. As you can see, the highest exponent of n here is 2. Pero yung n squared minus 9 ay nakaloob ng square root. So, 2 divided by 2 ay 1. So, somewhat, the degree of the denominator is somewhat 1. And the degree of the numerator is 0. So, the difference in the degrees ay 1. Thus, you might want to take your c sub n to be 1 over n. So, let c sub n be equal to 1 over n for all n. If that is the case, then this infinite series diverges since it is a harmonic series. Applying the limit comparison test, we have to look for the limit of b sub n over c sub n as n goes to positive infinity. Replacing values for b sub n and c sub n, we get the following. Before we proceed, we use the fact that square root of n squared is equal to absolute value of n. This is by definition of absolute value. And the absolute value of n is equal to n whenever we are taking the limit as n goes to positive infinity. Again, we can replace the absolute value of n with n since we are taking the limit of this one as n goes to positive infinity. Thus, we can replace n with square root of n squared. So So this is just equal to this 1. And we know that this limit is just the square root of 1. So you have here 1, which is a positive number. Therefore, by LCT, kung anong nangyayari dito sa infinite series na to, yun din yung nangyayari sa infinite series na to. Since we know that this infinite series diverges, by LCT, this infinite series also diverges. Thus, hindi kasama yung 0 sa possible, hindi kasama yung 0 sa interval of convergence natin. Tatanggalin natin yung dalawang possibility, we are left with this one. Kasi sabi natin, 0 is not included in the interval of convergence. For us to determine whether 1 is included or not included in the interval of convergence, we have to check for the convergence when x is equal to 1. If x is equal to 1, this infinite series is just equal to this one. This is an alternating series, so you might want to apply the alternating series test. For you to apply the alternating series test, you have to verify whether 1 over square root of n squared minus 9 is positive for all n. We have verified that earlier. Sabi natin, for all n, ranging from 4 to positive infinity, 1 over square root of n squared minus 9 is always positive. Thus, we can apply the alternating series test. Applying the alternating series test, let us call C sub n, let's call 1 over square root of n squared minus 9 to be your C sub n. If that is the case, if we want to apply the alternating series test, we have to verify two things. These two things is this sequence ultimately decreasing, o kaya naman is this limit equal to 0. So you have to verify whether these two are true. If it is true, then we say that this infinite series converges. So why is that this sequence ultimately decreasing? So bakit? Kasi if you let f of x be equal to 1 over x squared, 1 over square root of x squared minus 9 for all x in the interval 4 to positive infinity, then f prime of x will be equal to negative 1 half x squared minus 9 raised to negative 3 halves times 2x. X squared minus 9 raised to negative 3 halves is always positive for all x in this interval. So this is positive as well as 2x. Times negative 1 half, we have negative. So this is less than 0 for all x in this interval. Since that is the case, we say that this sequence is strictly decreasing. Since it is strictly decreasing, we can say that it is ultimately decreasing in return. For the second criteria, we have to verify that this limit is equal to 0. So limit of c sub n is just the limit of 1 over square root of n squared minus 9 as n goes to positive infinity. As n goes to positive infinity, n squared minus 9 goes to positive infinity. Principal square root of positive infinity is positive infinity. 1 over positive infinity is 0. So this is 0, therefore this limit is equal to 0. Since these two are true, we say that this infinite series converges by the alternating series test. Thus, included yung 1 sa interval of convergence natin. Therefore, as a conclusion, we have the radius of convergence equal to 1 half, and our interval of convergence is equal to this interval. Parehas ba kayo ng nakuha ang sagot or conclusion? I hope so. Sagutan na natin yung number 4. For number 4, we have the following. So we have this infinite series for any real number a. So kahit ano daw yung value of for a, ano yung magiging radius of convergence mo at interval of convergence. So, ang gawin natin, let A be equal to, let A be any real number. So, you start with that. Let's assume that A is a real number. And then let's call each term in here E sub n. We wanted to apply the ratio test. Therefore, we have to verify whether each term in this infinite series is non-zero. But each term in this infinite series is non-zero only when x is not equal to a. So we exclude the value a before we proceed with the ratio test. So for all x that is different from a, we take the limit of a sub n as we take the limit of the absolute value of a sub n plus 1 over a sub n as n goes to positive infinity. As you replace values for a sub n plus 1 and a sub n, we get the following. So this is your a sub n plus 1, this is your a sub n, reciprocal of a sub n. So x minus a raised to n plus 1 over x minus a raised to n is just x minus a. So you can factor out the absolute value of x minus a. What will be left to you is the limit of the absolute value of n factorial over n plus 1 factorial. Magka-cancel out yung n factorial since n plus 1 factorial is just n plus 1 times n factorial. So magka-cancel out yung n factorial, may matitirang 1 over n plus 1. And we know that n ranges from 0 to positive infinity, thus the absolute value of 1 over n plus 1 is just itself. So you will be left with the following. Yeah. Okay. So since we know that absolute values are always greater than or equal to 0, but we have assumed that x is not equal to a, so x minus a is not equal to 0. Therefore, x minus a is a positive real number. So as you take the limit as n goes to positive infinity, this just goes to 0. So you have here 0, and we know that 0 is always less than 1. Therefore, if you consider any value for x that is different from a, by the ratio test, this infinite series converges. Since you consider any value for x that is different from a, it turned out that this infinite series converges. Now you recall that every power series is convergent at its center. So in return, this infinite series also converges when x is equal to a. Therefore, this infinite series converges for all values of x. Therefore, your radius of convergence is infinity and your interval of convergence is the real number line. And this is your conclusion for number 4. For number 5, we have the following. So this is an alternating series, as you can see. Moreover, x minus 2 has exponent 1. So x minus 2 is independent of n. Again, as you observe our infinite series, the exponent of x minus 2 here is 1. So x minus 2 is independent of n. If that is the case, we can factor out x minus 2 from the summation. So this is just equal to this one. So meron kang x minus 2 times this infinite series, which is an alternating series. So you might want to apply the alternating series test for this one. But before you apply the alternating series test, you have to verify whether 1 over n is positive for all n. Since our n ranges from 1 to positive infinity, 1 over n is always positive. Thus, you can apply the alternating series test for this infinite series. Let's call 1 over n to be c sub n for all n. If you want to apply the alternating series test, we have to verify two things. those two things are these two. So is this sequence ultimately decreasing? That is the first question. And is this limit equal to zero? That is the second question. For the first question, let us let f of x be equal to 1 over n, be equal to 1 over x for all x in this interval. Since that is the case, then f prime of x will be equal to negative 1 over x squared for all x in this interval. Since our x is from this interval, 1 over x squared is always positive. Times a negative number, we have here negative. So f prime is negative for all x in this interval. Thus, we say that this sequence is strictly decreasing. Since it is strictly decreasing, it is ultimately decreasing in return. So we have verified the first criteria. For the second one, we have to look for the limit of 1 over n as n goes to positive infinity. This we know to be 0, so this limit is equal to 0. So verified na rin yung second criteria. Thus, by the alternating series test, we say that this infinite series converges. Ngayon, ang ibig niya lang sabihin, if you consider any value for x, yung x minus 2, real number pa rin siya. Again, if you consider any real number x, yung x minus 2, real number pa rin siya. So if you multiply any real number to an infinite series that is convergent, yung resulting infinite series mo ay convergent na rin. Again, if you multiply any real number sa isang infinite series that is already convergent, yung resulting infinite series mo ay convergent na rin. Therefore, this one is convergent for all values of x. Therefore, that only means that the radius of convergence is infinity and your interval of convergence is the real number line. And that's how you answer number 5. Okay. For our number 6, we have the following. As you can see, if you observe the given, yung exponent ni x dito ay 1, katulad nung nasa number 5. I want you to try this one out before proceeding to the third video of our discussion class. So, bago nyo panoorin yung third video ng ating discussion class, i-try nyo muna on your own na i-determine yung radius of convergence and interval of convergence of this one. Okay? See you on our next video. Bye!